Last time we took a look at section 2.3 and we had talked about Venn diagrams with different kinds of set operations, in particular intersections and unions, and I believe we're on example 2. Everybody good with that? Awesome. And so we have 3 overlapping circles. We had our rectangle, we had 1, 2, and 3, and we would label them as such. Every semester I think that when we get to this test, I'm going to have more people that actually put numbers in than I had before. And every semester I'm kind of disappointed. The very first thing you do after you draw these pictures like this is to put numbers in your circles. So if there are no numbers in your circles, you don't get any of the credit on the problem. It will say something like, no work equals no credit. Okay, and the work is the numbers. Now we're not done with them, but that's where you have to start. The numbers are where we start. Okay, they don't necessarily have to be done 1, 2, 3 across the top and through the middle and down and so forth. But if you're sort of hoping to compare them to somebody else's, it helps for us to all use the same numbers in the same place. So this is where I always draw my numbers. All right, looking at the information that we're given, we have A intersect with B and then union C. And just like with algebra, we want to start on the inside of parentheses and work our way outward. So this is the piece that we're going to do first. So the sets that are included inside of there are sets A and B. So I'm going to list each one of them, and I'm going to list next to them the numbers that correspond to the set. So what numbers are in circle A? Right, 1, 2, 4, and 5. We list them all. Any part of circle A's numbers. And what numbers are in circle B? That was a terrible 5. Let me try that again. 2, 3, 5, and 6. Okay, so we've listed all of the information that is currently in our diagram. And now we're going to combine them with whatever set operation it tells me to. And what is that set operation? Intersect. So, what did you learn from the video last time intersect means? It's where they run together. It's what they have in common. Okay, it's the pieces of information where they overlap. So which of these numbers fit that description? 2. Oh, that was really thick. I didn't mean that. All right, 2 and 5. They're in both lists. So the intersection would be 2, 5. The next item says C, right? I've finished everything inside the parentheses, so I'm done with that. Now I'm working on the part on the outside to include that piece, which is union C. So I list, again, all the items that are in C. So which numbers are included in circle C? 4, 5, 6, and 7. Okay, so that piece is done. And now again, I'm going to combine these two. It's kind of like when you're working with addition, you add something and you add something else. It's like that. So I'm going to combine A intersect B with whatever operation it said, and it said union C. So what did you learn that the word union meant last time? All of it together. You get everything. Okay, it's not about overlaps or anything like that. You just get it all. Okay, so what numbers are included in that description? 2, 4, 5, 6, and 7. Very good. Now, that is our answer if we go back to our diagram and we include it. So we're supposed to use our diagram to show the answer with shading. It always talks about shading. So we need to shade in the regions that correspond to 2, 4, 5, 6, and 7. So here's 2, 4, 5, 6, and 7. Now, let me just say, in case I didn't say it on the video because I don't know, this is not the only way to do this problem, and I'm fully aware of that. In fact, I have not always done problems like this. However, I had a student show me one time this as a way that she had learned it, and I fell in love with it. It was so much clearer than what I had been taught, and I've used it ever since. There are problems, and this is probably one of them, that you could probably reason through this pretty well without doing any of the work. You might be able to get the right answer and do it okay. But the more complicated things get with complements, the more difficult that process is to do without writing some information down. So this is the work I'd like to see. I would like to see the numbers and the shading, all of it, okay? All right, I think we have one more. And such an example it is with complements in addition to what we had before. So start with the same diagram we had to begin with, rectangle with 3 circles, labeled A, B, and C. And I didn't do it in the last one, but technically it's the universal set out there, so I should label that a U. And then I need to put numbers in there. Always going to have numbers. 1, 2, 3, 4, 5, 6, 7, and 8 on the outside. Don't forget that piece. Okay, inside the parentheses, what 2 sets are we comparing? A and the complement of B. So those are the ones I'm going to write down. I don't need to write down B on this one, right? I don't have B as a set. I have the complement of B as a set. So don't go writing down extra information. You're going to confuse yourself. Just write out the information you've been asked for. What numbers are in circle A? 1, 2, 4, and 5. Okay, so B complement will mean everything that's not in B. So now I want to list all the numbers that are not in circle B. And what numbers are those? 1, 4, 7, and 8. Good job, and good job remembering the 8. Again, it's an easy one to forget. Okay, so what set operation am I going to use to compare these 2 sets? Intersection. And intersection again means what? Where they cross, what they both have in common. And what do they have in common? 1 and 4. So I'm going to list 1, 4. What's the third set that I'm comparing these to? C complement. And what numbers are not in C? Nice. What set operation am I going to use to compare these guys? It's another intersection. So what do these have in common? 1. So the shading for this one's really easy, right? Yeah, just circle 1. All right, so one of the things that we've done with Venn diagrams in this section, the one we've done so far, is identifying which portion of the diagram we're referring to, right? Where's the intersection and the union of all these 3 sets, or 2 sets? We're going to move a little bit beyond that. This is just a numerical example, but we'll do one with context in a minute, to take a look at how else Venn diagrams can be used. Now, the numbers that we see here are not just identifying, like my numbers 1 through 8 did, a region of the picture. They actually have context in what they mean, and we'll do an example of that one after I show you just the nitty-gritty of how to. All right, so we're going to draw an appropriate Venn diagram and use the given information to fill in the number of elements in each region. So, you see 3 letters listed, right? A, B, C. So my picture starts out much like it did on the last ones, with this rectangle and the 3 circles inside, labeled A, B, C. Okay, our goal is to fill in numbers throughout this diagram in the 8 different regions that match with the information given. So for example, the first piece of information says n of A equals 24. What that means is that all of the regions where A is combined equal 24. It doesn't mean just the part with the A only little spot right out here is 24. That's not what it's saying. It's saying the entire circle A adds up to 24. So hopefully you realize that's sort of a problem. I don't know what numbers to put where. I just know they have to add up to 24. And there are lots of places I could put, lots of numbers I could put in those places to add up to 24, right? I mean, like maybe I choose 20 and 2 and 1 and 1. Or maybe I choose 12 and, add the rest of them up to 12. I mean, I have lots of choices. So that piece of information, n of a equals 24, is really not a good place to start. But if n of a equals 24 is not a good place to start, then n of b and n of c probably aren't for the exact same reason. So that first line of information, not real helpful. Let's take a look at the second line. The second line says n of a, b, a intersect b, is 10. So a intersect b is this sort of football shape right here. How many regions are in that football shape? 2. So that's like way better than 4. But even so, I mean, how many different ways can I add 2 numbers together and get a 10? Quite a few. I mean, it's not nothing, right? I mean, it's not like I know for sure it's 5 and 5. I don't. I still have lots of choices. And again, the same thing happens on every one of these combinations around here on the middle row. I've got 2 overlapping regions, not real helpful. But what happens on the third row? What does this piece of information tell me? It tells me information about one specific piece on this diagram, the very, very middle, because it's supposed to be the intersection of all 3 sets. That's good stuff right there. Because if I fill this 6 in right here, and we'll mark off that we did it, we'll mark it off right here. Then if we go up a line where we have the intersecting 2 regions, check this out. Here's A intersect B now. These 2 regions have to add up to 10, and I know that one of them is 6. What's the other region? 4. So I can fill in my 4. B intersect C. That would be here. Those have to add up to what? 8. And I've already got a 6, so what do I have left? 2. And we'll mark that one off. The next one is A intersect C. That's here. They have to add up to what? 15, and I already have 6. What is it? 9. Good. So I've got 9. Okay, everybody getting the feel for what we're doing? We're working our way kind of from the inside out. Now, in some of the examples you're going to have in your book, they're going to draw you a Venn diagram that doesn't necessarily look like 3 overlapping circles. Maybe they have 2 overlapping circles and a disconnected circle or something like that. You're just going to assign numbers, the same thing we did, when we were doing these numbers like this, and look for overlapping regions. Everything's the same. Their diagrams sometimes just are even easier to work with, just as a FYI. All right, if we go back up to sort of line number 1 now, n of A is 24. Well, that's circle A right here. All of it has to add up to 24. 3 of the pieces are already labeled. How much is in those 3 pieces? 19, and I need a total in this circle of what? 24, so how many am I missing? So there's a 5 in the A only part of the circle. Circle B over here. How much do I already have listed in that circle? 12. How many do I need? 24, so I need 12 more. Yeah, some of you are answering the other part of it. Yeah, is that okay? Do we get it? Okay, good. Circle C, down here in the bottom, how much do I have? 17. How much do I need? 26, so 9 more, right? Okay, so I've highlighted as I've gone. Hopefully you've kind of kept track of them at least. There's one more piece of information that's given in this particular diagram. What is it? The total of all of them, including the outside piece that I don't have anything written in yet. So I need somebody to grab their calculator and add up all of these numbers that we have, 5, 4, 12, 9, 6, 2, 9, and see how many is missing to give me the 50 that I needed. It's 47. So how many am I missing, Taryn? 3. And there's a 3 on the outside. Okay? So when I do a problem like this, every time I teach it, I feel like this feels like a puzzle. It feels like something I would do in, like at the bookstore when you buy, like the crossword puzzle and the Sudoku puzzle. This kind of feels like that to me. But there is actual application of it. It's not just for the fun of doing some numbers with, some addition facts. It is fun, but this is actually why we're doing it. It's for some word problem kind of examples. So we're going to start with one that's kind of small, and then we're going to do one that's a little bit bigger. Joe Long works on albums for musicians. Last year, he worked on 12 projects. He wrote and produced 2. He wrote a total of 5, and he produced a total of 7. And then we have some questions about Joe Long and what he did. Now, as we're taking a look at this, Venn diagrams are what's going to be able to help us solve these problems. So if you will, go ahead and create a Venn diagram. And what you have to decide to start with is it 2 circles or is it 3 circles? So going back to the description, what does it sound like this one is? It is 2. What are those 2 circles going to be? Right, they're going to be wrote and produced. And just write that on them. This is wrote and this is produced. Feel free to abbreviate. Now we're going to look at the information that's given about Joe. We have 12 projects total, so that's all the pieces added up, right? Not where we want to start the diagram. It says he wrote and produced 2. Is that information we can use to start with? It is. So I want to show you that just because this example had almost the last piece of information is the one I wanted, it doesn't always show up that way in the context of the problem. This one, it showed up in the middle. Wrote and produced 2. So where's the number 2 going to go? In the middle. Good. So we've taken care of this piece, right? Wrote and produced 2. It says he wrote a total of 5. So what number am I going to put and where will I put it? We're going to put a 3 in the wrote circle. And how did you get 3? You're right, it's 3. Right, exactly. The 2 numbers have to add up to 5 because all of those projects so far in my picture are written by Joe. We've just already accounted for 2 of them. Good job. So we've got the written total of 2, a total of 5. And now we need produced a total of 7. So there will be a 5 in the outside circle for produced only, right? That's what that really is. It's produced only. So the 5 and the 2 add to 7. Am I done? No. What do I still need to do? Yeah, I've got 12 projects here, which means there are 2 left over on the outside. This diagram will now allow me to be able to answer the questions on the previous slide. Here's a mini version of it. Okay, so how many projects did he write but not produce? 3. How many projects did he produce but not write? And how many projects did he neither write nor produce? Okay, so answering the questions should be easy after you've done the hard work of creating the diagram, okay? Answering the questions should be very straightforward. All right, I think it's the last one for today. Am I lying? Oh, it's almost the last one. Example 5. A youth group was asked questions regarding the songs that they had learned as children. Upon surveying 34 youth, the following were obtained. 15 had learned Jesus Loves Me. 19, the B-I-B-L-E, 28, This Little Light of Mine, 13, Jesus Loves Me, and This Little Light of Mine, 15, Jesus Loves Me, and the B-I-B-L-E, 14, the B-I-B-L-E, and This Little Light of Mine, and 13 had learned all 3. How many different circles does this diagram have? 3. It has 3. So we're going to draw our diagram, and we're going to draw 3 overlapping circles. And we can label them with at least an abbreviation of the name of the song. So the first one I'm going to write in is Jesus for Jesus Loves Me. I'm going to write in the B-I-B-L-E. And then I'm going to write in light for This Little Light of Mine. All right, so which of these pieces of information is the most useful place to start? The 13 at the bottom, the 13 that had learned all three. Because I'm going to put the 13 where? Right there in the middle. So far, so good? All right, what would you like to do next? Almost all the numbers are unique at this point. The 14 that's right above my 13, okay? This one right here, whoops, I didn't mean that. I meant this. It said 14 had learned the BIBLE and this little light of mine. So the BIBLE and this little light of mine would be this piece right here, right? They've got to add up to 14. So how many more do I need in that portion of my diagram? 1. What would you like to do next? The 15 at the bottom, so to speak, right here, right? 15, Jesus loves me in the BIBLE. So that will be a 2 in the top overlap. What's next? 13, Jesus loves me in this little light of mine. So what am I going to do? Yeah, totally cool. No problem putting a 0 in my diagram. You can't put negatives in there. That's not okay. But zeros are okay. There's simply no extra people in that category. All right, now what? 28. You guys want to go bottoms up? I like that. All right, 28 is this little light of mine. Okay. So this whole circle is this little light of mine. How many are in it so far? 14. And how many do I need in it? 28. So how many am I missing? 14. Okay. How about we go with 19 next? 19, the BIBLE. So here's the BIBLE. There's 16 in there now, so I need 3 more. And then I've got Jesus loves me. The top, there's 15. So what do I have? I got another 0. I know it feels funny to put zeros in it, but it's okay. Am I done? No, but I'm really close. What am I missing? The universal, the 20 or the 34, excuse me, youth. So, taking a look at my diagram, how many youth are currently accounted for? 33, so I need 1 more out here. And we're going to answer a few questions. How many of the children had learned exactly 1 song? So where on this picture would exactly 1 song be? Tell me the numbers you're seeing. 0, 3, and 14. Did everybody see that? Okay, so as you're answering these kinds of questions, I would strongly encourage you to write those down. 0 plus, was it 3 and 14? Yes. 3 plus 14. And here's why. If for some reason there is a mistake on your diagram, the only way that I have to check your work on the answering of the questions is that it matches. And if you're getting an answer that's not what mine is, but your diagram is also not right, I have no way to sort of go back and offer partial credit because I don't know what you were counting. Okay? So this is for your protection. And here you get a total of 17, right? All right, how about at least 2 of these songs? What does at least 2 mean? That's not at least 2. That would be at most 2. So what is, just start with the phrase, though, for me. What does the phrase at least 2 mean? 2 or more. 2 or more. So it's the 2 categories, which would be these 3 pieces, or 3, which would be the one in the middle. So it is all the overlaps in my diagram. At least and at most trip people up, so be careful. At least 2 and at most 2. So at least means 2 or more. So in this diagram, I would have 2, 0, 1, and 13. And again, I would write in that. I encourage you to do so. 2, 0, 1, and 13. And if I add those, did I get those numbers right? Yeah, okay. And if I add those together, what do I get? 16. How about none of these? That's 1. And this little light of mine only? 14. So some of these answers come very quickly. Others we have to add pieces of diagrams together. Any question on this one? All right. Last question for today. Is the Cartesian product commutative? Why or why not? Okay, so you guys learned about the Cartesian product on the video that you watched. Tell me what you know about the Cartesian product from before. And yeah, flip back if you need to, that's fine. If I had a set A that's A, B, C, I'll use numbers because it'll be an easier diagram to think about in a moment. And I have the numbers B that are this. What does the Cartesian product look like? What did it look like? They're like ordered pairs, you bet. So we take the first item from set A because it's listed first, and the first item from set B. And then the first item from set A and the second item from set B. And the third item from, or the first item from set A and the third item from set B. I'll finish my diagram and then we can talk about the answer to this actual question. So I have 2, 1, 2, 3, and 2, 5. And then 3, 1, 3, 3, and 3, 5. So this is a Cartesian product. It is a set of ordered pairs. That's what it is, a set of ordered pairs. All right, so the question is that if I wrote down A cross B, which I did, make it a little bit smaller so I have more space. And if I were to write down B cross A, would I get the same elements? No, Brianna says no, and she's right. Why would I not get the same elements? I mean, I would also get a 1, 1, right? That one would match. But then I would have a 1, 2, and a 1, 3. Are all of those elements of both sets? No. 1, 2, I'm not finished with the whole diagram, but 1, 2 is not over here, is it? It's not. I will not get the same items. And in general, the reason that I will not get the same items is because, for example, the 1, 2 that I'm failing to have is not the same as 2, 1, is it? And if you think about it from a Cartesian coordinate plane, you know, like you do in algebra or geometry, you know that. You know that the ordered pair 1, 2 does not equal the ordered pair 2, 1, right? So the order in which we do the ordered pairs is different. It matters.
I'm sorry, I'm still a little bit confused on how you got the 1, 1, 1, 2, 1, 3 for
Okay. It's not times. It's a product, but it's not times. You take the first item here, and you pair it up with the 3 items here one at a time. So that's why there's a 1, 1, a 1, 3, a 1, 5.
I'm talking about all the other stuff.
You just do it in the other order.
Oh, okay.
You do it in the other order. So you take the 1 at the bottom in set B, and you pair it up with the 1, the 2, the 3 on the top. And I didn't finish my diagram, so that might have helped. So the next one would have been 3, 1, 3, 2, and 3, 3. Yeah. And of course, we'd have our last column on there. But the items are not going to match up. Some of them do, but not all of them.